Welcome everyone. So in this tutorial, we are going to learn about two very important network security concepts in OCI, which is security list and network security group. So by the end of the session, we will be able to completely understand what security rules are, what security lists are, and what is network security group. What is the key difference between net security list and network security group, and when to use which approach. So all these things we will be discussing in this tutorial, and also I will be demonstrating one use case in which we will see like how security list and network security group is different and when to use which one. So let's get started. So let's understand what is OCI VCN security rules. So a security rule in OCI is actually a network access control. So which determines like what traffic is allowed to enter, which is also known as ingress, and which traffic will leave the resources within the VCN, which is also known as egress. So it controls the incoming traffic, the ingress, and the outgoing traffic known as egress. So in a simple term, so security rule is nothing. It's just it will act like a gatekeeper for your cloud resources, and it will decide like which network traffic is permitted and which traffic will be blocked. So these are the components of our security rules. So we have the source type and the value. Like here we give the IP address, or we can also give the CIDR block to designate multiple IP addresses. And here you can see that this is how we give the CIDR block. So we also give the IP protocol, like which type of protocol we will be permitting. So normally we use the TCP and others like UDP, ICMP, and even if you want, you can allow the all the ports. So we also have to give the source port range, and that's optional. If you want, you can allow all the ports from the source, so you can mark it as a like a star. And also we will designate the destination port range, so like that here you can define it. And type is most important, like what type of traffic it is, which type of traffic we are allowing. So by default, so everything is denied in OCI. So we have to define the rules which will actually give you the permission, which will actually allow the traffic from the VCN. And also you can give the description. So description should be given so that you can easily identify the purpose of that particular rule. So these are the examples of defining the security rules. So here we have defined four rules. So here we can see that the first one is the ingress traffic, which mean we are allowing the traffic from this particular CIDR. So now this CIDR is for all the IP addresses. So in the VCN, in the OCI world, so which means that we are allowing the traffic, the incoming traffic from all the IP addresses from using the TCP port. And also which port we are allowing. So we are allowing the port number 22, which is nothing but it's the SSH port. So by if we use this particular rule, which means that if we have one of our compute machine or virtual machine, so in that what we are doing, so we are allowing the SSH. So anybody can SSH to your virtual machine from the internet. So like that, you can define other security rule. You can allow the HTTP traffic port, which is at port number 80, which is this one. And you like that, you can use other types and sources. You can mix and match all these things. So when we define all these rules, so there is a evaluation order for that. So which means that rules are processed in order from top to bottom. So first, this particular rule will be evaluated, and after that, the next rule will be evaluated. And if this rule is matching with the source, so that particular traffic will be allowed. And if the rule is not matching, so the traffic will be denied and it will be dropped. So by default, as we know, like everything is denied in OCI. So this is the layout, like how we define the VCN security rules, how it works. So we have one inbound traffic coming from the internet in that VCN. So we have the subnet, and here we can see the security rules. So either it can allow the traffic, or by default it is denied. So these are the few best practices that you should follow. So you should follow the principle of least privilege. So by default, you should be not giving the entire access. That means instead of using the entire range of the IP addresses, you should give the particular CIDR, so that only the set of IP addresses should be allowed. And also, you should be reviewing your rules regularly, so that in case any rule that you see that it is not required, you can simply delete that. You can remove that. Use the descriptive names for easy identification. So these are the few best practices that you can follow while defining the security rules. And these are the key benefits of using the security rules, so which improves the security by controlling the network access. It simplifies the traffic management, and it supports both stateful and stateless definitions. So now let's understand what is stateful and stateless security rules. So when we first talk about stateful security rules, so these are the rules which automatically track the state of the connection. So which means that when you allow a traffic in one direction, the response traffic, which is the other direction, it is automatically allowed. So that regardless of any explicit rule. So if you write one stateful rule, so it will allow the traffic in both the sides. So this is the example of one of the TCP connections, so which is allowing the traffic from the both the sides. So let's understand like what are all these packets are. So suppose you want to make a call to your server. So what the client will call the server, and it says like, hello, can you hear me? So which is a synchronous packet call. Okay, so client will say like, hello, can you hear me? So on upon hearing this word, so what server can do? So it can reply by, yes, I can hear you. Can you hear me back? All right. So that is the synchronous response with the acknowledgement, which means the server is acknowledging that, yes, I am able to listen to you. And also it's asking like, do you listen to me as well? All right. And after that, so client will again reply back saying that, yes, I can hear you too, which is the acknowledgement packet from the client. And once this handshake is made, like this is a three-way handshake. So once this one is made, so after that, the data can flow through and the response will be automatically allowed. And here we can see that this one is the stateful traffic exchange, so that once we establish the connection, so automatically the rest of the connection will automatically be allowed. The return traffic will be allowed automatically. So what is the benefit of this one? So the benefit is like, for example, if we have allowed the connection, so need not to like again ask for the identification. So once we establish the identity, so that after that, so connection will be allowed. So suppose in any case, like if we send the synchronous call, and after that server sends us the synchronous and acknowledgement call, and at that point in time, so what happens that if the synchronous and acknowledgement call fails in between in some network, so in that case, so if the TCP will be using only two step, which is sending and getting the reply back. So what will happen? So if the synchronous acknowledgement call is lost, so server would incorrectly assume that connection is ready. So that server can start the connection. It will allocate the memory, open the session, and wait for the data, which will never arrive because the connection has lost in between. And that's the reason why OCI stateful rules are there. So it cares that all these handshakes are done, so that In any case, if the connection is lost in between, so the acknowledgement will not be sent, and then we will not be starting the session. So server will not be sending the SSH response and the HTTP response. So which means that the traffic should not be allowed if any packet will be lost. So that's reason the stateful rules are very useful. So it covers all these packets exchanges and allows the return traffic automatically. And also, like, what is a stateless rule? So in that stateless rule, so they do not track the state of the connection, which means that so all these handshakes, they if these are not met, so the return traffic is not allowed. So here we can see in the picture that it sends the synchronous, and then if the synchronous and a acknowledgement is lost, so the entire response, the data response, the exchange will be stopped. So in the stateless security rules, what happens that it does not keep the track of the connection state, and we need to explicitly define both the rules in both direction, the incoming direction and the outgoing direction, so which is like a tighter control. So the best practice is normally we will be using the stateful rule so that it covers both the directions, and you can use the stateless rules in case you want to define the fine grained control and you have a specific requirement to check the connection at each level. So always follow the principle of least privilege and allow only what is required. You should not be allowing the entire IP range, just like with our CIDR 0.0.0/0. So that's the CIDR for the entire IP ranges. We should not be allowing that. But in any case, if you still want that, you can, in that case, you can load, but just be careful for that. And always review your rules and audit logs regularly so that you found in case you found any mistake, so you can correct it, and you should be testing your rules thoroughly to avoid any unintended access or the outages. So just to highlight, these are the differences between the stateless and stateful security rules. All right, so here we can see that in the performance, we can see that the stateful will have the higher performance because once the connection is established, so the return traffic is automatically allowed. But in case of a stateless, so we have to evaluate each packet independently. So that's the reason there will be slight a reduction in the performance of our network. And these are the use cases like in which you will be using the stateful and the stateless rules. So default behavior. So this is the default behavior in OCI security list and network security group, which is the stateful security rules. But if you want, you can still go with the stateless. So this is what stateful and stateless security rules are. So now let's understand what is a Oracle Cloud Infrastructure vSIN security list. So security list is like in which we will be putting the security rules, and this one is allowed. This one operates at the subnet level. So for a given subnet, so what you can do, you can define the security rules, a security list. In that, you can add the rules. So you can define your own rules. So by default, when you create the VCN manually, instead of using the wizard option, so that time, so what happens that it will automatically add the security list to your VCN, and there are few security rules which are automatically added to that. So these are the things that governs the rules in the security list. Just like our security rules, you have to give the source and destination, IP protocol, source port, destination port, and direction. So by default, so everything is denied. So you have to write your own rules to allow the traffics. So this is how security list will work. All right, so next is the VCN network security group. So it works on at the VNIC level, that means at the components level. So security list works at the subnet level, but network security group works at the VNIC level. All right, so NSGs or network security groups are basically for micro segmentation and the granular controls of the instance traffic. So it again controls both the ingress and the egress traffic. So the as we know, the default behavior is the denial of all the traffic access by default, and we have to write our own rules to allow the traffic. This works in a similar fashion to security list. So the only difference between this security list and the network security group is that security list works at the subnet level and network security group works at the VNIC level. So this is one demonstration in which you will be understanding like how security list and network security group works in the VCN. So suppose we have three servers in the same subnet, which are designated as A, B, and C. So the requirement is that all the three servers should permit the SSH on port number 22, and only the server A will be allowing the ICMP, which is the ping command. So now by using only the security list, these two requirements are not fulfilled. We cannot fulfill these two requirements. The reason because if we allow the traffic at all the levels for three servers, and if we want that only a single server should be allowed, so in that case we cannot write that at the security list level. So we need to have some another control which will only work for a given compute machine or the virtual machine. So in that case, what we can do, we can use the network security group. So the first operation would be like all servers permitting the SSH connection at port number 22. So for that, what we can do, we can put a security list and we can write this particular security rule. Here we are allowing the traffic from all the sources, and this is the TCP protocol, and this is allowing at the port number 22. And here we have given the description that it allows the traffic 22, which is the SSH remote login protocol. So by this particular security rule, so we are allowing the traffic for the SSH connection. So now for the point number 2, which is allowing the traffic access at only at the server A, so which we are allowing the ICMP protocol, so we are allowing the ping commands. So in that case, we need to create this particular network security group for the ICMP protocol. So in that case, so we'll be writing our again the security rule, which is the ingress traffic, and this is, you can see that we are allowing the protocol of ICMP. So the first thing in which we use the security list, so it covers the SSH connection, and here we define the network security group, which covers the point number B, which is we are only giving the access to server A for the ICMP. So that so now all other machines, virtual machine like B and C, will not have the access to this ICMP protocol. So this is how we will be splitting the accesses, and this is how we can control the traffic access. So this thing we will see in the demonstration, and let's see how it works in the OCI word. So before starting the demonstration, so let me show you the documentation for security rules so you can follow this documentation. So to know more about security rules, security lists, and network security groups, so you can follow this particular documentation. And here this basically compares the difference between the security list and network security groups. So here we can see that security list applies to all the VNICs in the subnet. So using that particular security list, and for the network security group, so this is only for the chosen VNICs within the same VCN. And so how to enable that? So simply we need to associate the security list with the subnet. But in case of NSG, so we have to add the specific vnix to the NSG. So the limitation, so limitation is like in the VCN. So what you can have maximum 5 security list per subnet. So that's the uh, limitation that we have. And also for NSG, so maximum 5 NSG per VNIC level. So just be careful for that. So follow this documentation and you can know more about all these components. So now let's jump into the demonstration. So this is our cloud console that we have logged into. So here we can see that this is our region Ashburn. For this demonstration purpose, so let's first create one new virtual cloud network. So for that, by using that, we will be creating 3 compute machine, the virtual machines. So let's go to navigation menu, click on this networking, and after that, click on virtual cloud networks. So this will display the virtual cloud network screen, and here you can see the compartment which is selected is this particular compartment. So what you can do, you can change the compartment, click on this link and select the compartment. So we will be putting all the VCNs in this network compartment. So select that. And here we can see that already we have this particular VCN which is already created. So now we will be creating the another VCN. So here you can see that this is the CIDR block. And under that, when we open that, we will be able to see the subnets. So this is the CIDR block for the entire VCN, and these are the subnets having these CIDR blocks. All right. So let's create another VCN. So let me go to networking and then virtual cloud networks again. Go back. So here we will start the wizard, which is the VCN wizard, which will automatically create all these components. So click on Start VCN Wizard. So here 2 options are there. So we will be selecting create VCN with internet connectivity because we want to connect from the internet to the machines that we will be creating. So select this option and then click on Start VCN Wizard. All right. So here you have to give the name of the VCN. So let's name it as demo VCN. So the compartment will be selecting network compartment, and here we need to select the CIDR block. So for this particular VCN, so this was our CIDR block. So now we need to choose a different one so that both the VCN should not overlap each other. So let's use 10.1.0.0/16. And after that, we have to select the subnet. So the subnet will be under this particular VCN only. All right. So let me have the same blocks. So like here in this particular VCN, so these were the 2 subnets. So which had 10.0.1 and 10.0.2. So similarly, so we will keep the starting thing as same with the VCN. And after that, we can have one as public subnet and then two as the private subnet. All right. So this is the big network and these are the 2 subnetwork within this big network. So here you can see it's a /16 and this one is /24. So the CIDR block should be here. You can see the ranges like it should be must be between /16 to 30, and you cannot change this particular value again. So just keep that in mind. And these are our subnets, the public subnet and the private subnet. All right. So here we have given the VCN name, the CIDR block, subnet, public subnet CIDR and private subnet CIDR, and click on next button. All right. So when we see this particular, because this one is the wizard, so all other components will be automatically created. So it will create the public subnet and the private subnet, and after that it will automatically create these security lists and route tables. So for this particular subnet, this will be the name of the public subnet. For this particular subnet, so this is the security list and this is the route table. And for the private subnet, this is the private subnet name, and this is the security list for the private subnet, and this one is the route table for the private subnet. And it will also create these three gateways: the internet gateway, the NAT gateway, and the service gateway. So here you can see that these components will be created. So once you reviewed all these things, so simply click on create button. All right, it will take some time. And after that, once it is ready, so we can view our VCN in the OCI. All right, so everything is done. Now we can click on view VCN to view our VCN. All right, so this is our VCN, which is now created. And here we can see these are the two subnets, private and the public subnet. If you go to the public subnet, so we can see that there is one route table which is attached. This is the route table. And in this route table, we have route rules. And these are the rules which is allowing the traffic from all these IP addresses, which is all IP addresses. So this is allowing the traffic at the which gateway level? So it at the internet gateway. So it will allow the traffic from the internet. So this is the route table for our public subnet. And if we go for our public subnet, so here we go to the public subnet again. So under that, we go to security. And here we can see that this one is the security list, which is attached to our demo VCN. All right, if we open this one, so we can see that there are few rules, security rules, which are automatically created. So these are the three rules. So now here what we can see that we are able to see that all the sources, all the IP addresses are allowing the incoming ingress, which is mean it's incoming traffic. We are allowing the incoming traffic from all the sources at this particular port number, which is 22, and this one is the ICMP traffic, which is allowing at the port number 3 and 4. And here we are allowing the traffic from this particular CIDR, which is the VCN CIDR at the port number 3. And this one is the egress traffic. We are allowing the traffic to all the IP addresses from all the protocols for our VCN for this particular subnet. All right, so our VCN is now created. So now let's create three compute machines. So for that, go to navigation menu, select compute, and then go to instances. So just change the compartment. So here we will be selecting the compute comp. So here we can see that we already created one instance, which is instance one. So now we will create three instances. So click on create instance. So this will be the instance A. You can select the availability domain, keep the shape and image same if you want, or if you want, you can change the shape and the image. So we will keep this one as the same. Click on next, click on next again. So here we can give the name of the VNIC, which is VNIC. We will name it as a VNIC. All right. So here we need to select the network, primary network that is available in network compartment, network COM. So here we can see that we have two VCNs. So we will be selecting the demo VCN. And now next step is to choose the public subnet. So again, we will select the network comp, and here we will select the public subnet demo VCN. All right. So let's keep the other options like that only. So here we need to select the SSH key. So we in the previous tutorial, so we had already generated the SSH keys. So we will be directly using that. We simply need to paste the public key. So in here, so let me open that particular public key so that we can directly put it here. All right, so this was the public key. So we will directly use this one, and then we will put it in this particular text box. All right, so we selected the network, demo VCN, selected the subnet, public subnet, given the public key, click on next. So we will keep the boot volume size similar, the same, whatever it's the standard size, which is of 50 GB. If you want to change it, you can check this option and you can change it from here. So for now, let's keep the same. We don't want to attach any block volume, so just skip that and then click on next. And then now here you just review the information. All right. So all these things we will keep the same. Okay, and click on create. All right, so here we have some API error which says that we have out of capacity. So these kinds of error will can come if you are using the free tenancy. So in that case, you have to change the uh, particular resource which is giving the error. So let's choose another shape. So it says that out of capacity for this particular shape in availability domain 3. So what we can do, we can change the availability domain or we can directly change the shape. So let's go back, which is the basic information. So here we use the AD3. So either you can change this particular availability domain or you can directly change the shape. So let me do one thing. Let me change the shape only. So click on change shape and let's use the Intel one. Select this option, VM Standard 3, which has one OCPU and 16 GB of RAM. Select the shape, close it, and click on next. And just review the information again and click on create. All right, so the instance creation has begun. So we can see the percentage completion. So this one is for instance A. So similarly, let's create the other two instances. So we will use the same thing. All the steps will be the same. Click on create instance, give it a name, which is B instance. Select the shape, which is our Intel shape. Click on next. and again next. This will be BVNIC. All right. So choose the VCN, demo VCN, select the subnet, which is our public subnet, paste the public key, click on next, next again, review the information. All right. Click on create. So instance B has begun the provisioning. So let's again create the instance 3, which is the C instance. Click on create instance again. So the steps are very simple. Simply name it, select the availability domain, select the image, choose the shape, which is our Intel shape. So click on next. If you want, you can enable the shielded instance or the confidential computing. Click on next. So this will be our CVNIC. Select the network VCN, which is demo VCN. Select the public subnet, which is public subnet demo VCN. We will keep this option by default only. Paste the public key that we already generated. So you can generate a different key. So right now what we are doing, we are using the same key just for the demonstration purpose, but normally you will have various different keys for each instance, and you can have your own vault to store these keys somewhere safe. Click on next. Keep the boot volume for the default size. Click on next. So just simply review the information. All right, so click on create. So this one creation has begun. So let's go back. All right, so now we can see that instance A is in running state, instance B is in running state, and instance C is in provisioning. And these are the public IP addresses. So now let's connect to all these instances which are up and running. So for that, let me open the putty. All right, so here we have to give the public IP. Let's copy from here, give it here, and under the connections, SSH, expand the SSH option. Under the authorization, expand it and select the credentials. So here you have to select the PPK key that you already generated. So let me select that particular key. All right, so I've selected the PPK key. So now at this point in time, so what you can do, you can simply save the connection. So you can name it as instance A and just save it. So now whenever you open the putty, so you can directly select this one, click on load. So it will automatically load all the configuration, which means the host name and the authentication key. All right, so let's click on open. So it will ask you to cache the key. The host key is not cached, so simply accept this option. And here we can see that we are now connected. So simply give the username, which is OPC. All right, so now OPC is now connected. So this one is our AV nick. You can see OPC at the rate AV nick. So which means that this is our instance A. And what we can do, similarly, we can open another putty session. So now as we have saved this particular session, so what I will do, I will click on this instance A profile and click on load. So it has now loaded the SSH. We can see it here, credential. Here you can see the connection key has been loaded. So now here we simply change the host IP address. So this will be our B instance. And then here, let's save this one as well, instance B. Click on save, click on open, and then similarly accept the host key. And after that, you have to give the login, which is OPC. All right, so here we can see that this is OPC at the rate BVNIC. So we are now connected to instance B. And now let's connect to instance C as well. So again, we will load any profile, click on load, and then change the public IP address, and then save it again. Click on save and just verify whether the credentials, the private key is available. So here we can see this is the private key. Go to sessions. All right, so given the public IP, click on open. Accept this option, click on accept, and then connection will be started. Enter the username, which is OPC. So this one is for the B instance, and this one is for the A instance. And now we can see that all three instances, we are now connected to all these three instances. So which actually covers the point A of our demonstration, which is all three servers should permit the SSH on port number 22. So now we are able to see that we are connected. We have connected to all these three instances. So which means that the point A has been covered. So we are successfully connected to all these. The second point was only server A should allow the ping command. So let's demonstrate this one. So let's see whether it is allowed or not. So this is a VNIC, and here we can see that ping and then the public IP for the other instance. So this is the public IP for B. Let's copy that. So from A, let's ping to instance B. All right, so we can see that this one is getting failed. So we have packet loss. So which means that we are not able to ping this particular IP address from our A machine and similarly from the B machine. So we should not be able to ping to A. Let's check that as well. So this one is the connection got lost. So what you can do, you can restart the session, right? So now we are connected to B again. So from here, let's do the ping to the A, which is 141.148 and dot 45.162. So here also we can see the same response, which means we are not able to ping it. So all the packets are 100% loss. And similarly in the C, so let's use the same thing. We have to restart it, which is OPC, use the ping. And again, here we can see that we are not able to ping it. So now let's review the configuration of our all these machines and see where we can make the changes. So here we can see that we have these three instances. If we go to A and if we go to the instance networking information, so here we can see that this is the route table and this is the subnet which is attached to this particular instance. And this one is our AV NIC. So if we open this one, so you can see that the AV NIC is attached to this particular instance. This is AV NIC, and this one is using this particular subnet. All right. So now let's click on this public subnet demo VCN because security rules are written in the security lists. So let's open this one. And here we can see this is the public subnet demo VCN. And if we go to the security, and we can see this one is the security list, which is attached to this public subnet. And here we have these security rules. We have two rules, ingress rules and egress rules. So these are the three ingress rules. And here we can see that we have ICMP and it is currently allowing the type as 3 and code as 4 as well. So what we can do, so we can edit this one, click on edit, and now let's change it to all. So simply remove it. So when you click on this type and the code, so we can see that we can select this option, which is ICMP types and codes. So here you can see all the codes and the types. So here we can see that type 8 is echo. So we have to allow this particular type and the code. So instead of that, we will simply allow all the types. If we leave it, so it will allow all and click on save changes. So now here you can see that we are allowing all the types and all the codes from all the IP addresses. So here also you can see that if we give this IP cider, so you can see these are the IP ranges from 0.0.0.0 to 255.255.255.255. So these many IP addresses are allowed. So let's use the same thing. And now let's restart our VCN A. And here you can see even before restarting, so we are able to see the ping commands responding. So now the ping is responding. So let's go to the VCN B, use the same command. So here also we can see that we are able to ping it. And this is VCN A. So let's restart this one. Login as OPC. And we will issue the same command. All right, so now here we can see that what we have done, so we allowed the traffic, the ICMP traffic at the security list. So now you can see all three instances are allowing traffic. So, but our requirement was to just allow the traffic on the server A for the ICMP. So instead of allowing all the server, only one server should be allowing the traffic. So how we can make this thing possible? So which means that if we use this one, the security list, so this thing is not possible. So how we can do that? So let's edit this one and change it to the previous one only, which was 3 and 4. That was the previous values. And let's stop it. And now you can see that we have some packet loss. Stop it at the others. All right, let's clear the consoles. All right. So even if you want, you can simply delete the entire rule. So let's click on remove. So now the rule has been removed. Let's remove this one as well. All right. So we have removed the ingress rules from the default security list, which is the security list for our public subnet. So now what we need to do, we need to create one network security group. So this is our demo VCN. So in the demo VCN under the security section, you can see we have network security groups. So now what we will be doing, we will be creating one network security group. So the name would be NSG for ICMP. All right. So next would be the direction. So direction will be the ingress direction. It is a stateless as no. So we will keep that as unchecked. So direction is ingress, source type. So source type is cider and this is the source. Let's select cider and let's mention the cider block, which is all the IP addresses and here the IP protocol. So the protocol will be ICMP and under the type and code. So we will keep it as blank, which means that all the traffic. And here the description We can give it as allow ICMP traffic. Okay, and click on create. So here we can see that the NSG has been created. Go to security rules. So this one is the security rule, and under the VNIX, so we can see that no VNIC has been added. All right, so now what we need to do, we need to associate this NSG to our VNIX. So let's do that. So we will go back to our instance under the compute instances. So we have our instance A. So this is currently running, and now we will go to the networking section of our instance. And here we can see the primary VNIC. So this is the name A VNIC. And here we can see this is the attached VNIC to our instance. All right, so here we have been navigated to a VNIC. So this one is the VNIC which is attached to our instance. And here you can see that network security group. So right now this VNIC does not have uh, any particular security group. So now what we can do, we will attach the one network security group to this particular VNIC. So click on edit. All right, so this is our network compartment. And in that, I think we created in compute comp only. So this was the security group. So simply select that one and click on save changes. So now here we can see that we have added NSG for ICMP. And now let's go back to our AV NIC. And before that, I think we need to restart it. Restart the session. Let's click on duplicate session. Log in as OPC. Let's clear the console. So we can see that we are still not able to ping this particular IP address. So sorry. So what we are doing here, so from instance A, we are pinging to this particular instance. So this particular instance was instance 211, which is B instance. So now what we need to do from B instance, we will be pinging the A instance. So because in our NSG, so what we have written that for this particular NSG, so we are allowing the incoming traffic from all the sources. All right, and this particular NSG, so we have attached to A, which means that from all the other IP addresses, so we will be allowing the ICMP protocol. All right, so let's connect to this B instance. Let's restart the session. So this one is the B instance. Here you can see OPC B VNIC. So from B, we will be pinging to A, which means that A will be receiving the traffic, which means it's a ingress traffic, and we have allowed at the port number. Sorry, the protocol has ICMP. Let's clear it. And here we can see that now we have successfully able to ping the instance A. All right. So this is how the NSG will work. So right now we are able to ping from B the instance A, and from A we are not able to ping the instance B, and similarly we will not be able to ping the instance number C. So this explains the concept of NSG. All right. So hope you enjoyed the session. So in this particular session, so we have covered the security rules. What is security rule? What is a security list? What is the network security group? What is the difference between security list and network security group? And how you can use the NSG and security list in the VCN. So thanks for watching the video.